Mr. Herman here, and this is exercise 2D, graphing straight lines. Now on my screen you should see straight lines, but on the worksheet that has been provided to you by the teacher, it should say graphing straight lines. Now before we head into this exercise, there's a few things I need to point out. I'm recording this on the 4th of February, which is a Friday. That means that I actually haven't effectively taught exercise 2C to you guys as of yet at the start of this recording, so there might be a few things that I may have mentioned within class in Monday's double that I have no idea what that could be, because I'm recording this prior to that. And the second thing I need to point out is that the learning goals and the success criteria for this exercise of exercise 2D can be found within the lesson plan that's found within Compass that's in today's class. So exercise 2D is a pretty straightforward one. There's only 2 examples that we're going to look into, and this is having the ability of graphing straight lines. Now you can see here that there are 5 different template examples that could be provided to us. Generally speaking, you might see it in the first 2 formats, and even the second one there could be an alteration, which I'll get to that in a second. The most generic standard linear format that you can get of a graph, which we've seen in exercise 2C, is y is equal to mx plus c, where your m is your gradient or your rise over run, also known as the slope, and the c is the y-intercept, where it hits the y-axis. And how we sketch this line, if you're giving a graph, and generally speaking most of the graphs are in this format, is you plot the y-intercept and then you use the gradient to plot another point. So you determine what its run is and then what its rise is, whether it's going up or down, depending on if it is a positive or negative respectively. And then with those 2 points you just rule a line through, which we'll see in the example here in example 1. The other template that you can see is when the y equals mx plus c is actually shuffled a little bit, and you have a format where you have ax plus by plus c is equal to 0, and the numbers that I've provided to you within the question, a, b, and c, are replaced with numbers, and these numbers could either be positive or negative. Now I'm just going to extend on this a little bit. There's also another format you might see where it looks like ax plus by is equal to c, and again that c can either be positive or negative. When it's in this format, in order to find the x and y intercepts respectively, you're going to let y equal to 0 and then solve for x, and to get the y-intercept you're going to let x equal to 0 and solve for y. And then again, once you find these 2 intercepts, you're going to plot these 2 coordinates and then you're going to rule a line through it. Another format which you might have seen in exercise 2C, which we've looked into, is the x over a plus y over b is equal to 1. A and b are your x and y intercepts respectively, and then again, once you've got your a and your b, you plot these 2 coordinates and then you rule a line through them. Now this is assuming that this here must be equal to 1. If it's equal to another number, you have to somehow force it to make it equal 1, and also provided that the coefficients in front of x and y are 1. The last 2 scenarios that you will get, and these are I guess special cases, is when you've just got a horizontal line, so your y is equal to some number of some constant. If this is the case, the equation is just a horizontal line that cuts through y is equal to c. Say for instance you had a graph or had an equation that says y is equal to 2, and this is a positive 2. At y is equal to 2 on the axis, you will have a line that cuts straight across at 2. And the other format, the vertical format, is when x is equal to some number, again some constant, which we name a. And the equation is a vertical line that cuts through where x is equal to that number. So if you had x is equal to -3, wherever you see -3 on the axis, you'll go to -3 and you'll cut a vertical line that splits straight down x is equal to -3. These are the 5 different scenario, or I guess templates, that you will see for linear graphs. We'll show you two examples and then you guys can get started on exercise 2D. So example 1, how you go sketching a really basic version of y equals 2x plus 3. At this point, this should be a pretty simple concept. If you need a little bit of a reminder, you find your gradient, which in this case it's the m, the constant in front of the x. This is 2. And you can see here it's displayed as 2 over 1. And the reason why we do this is, again, just to indicate that this here is your rise and this here is your run. So every 1 unit we go across to the right, we are going 2 units up. And that's how you can determine your second point after you've got your y-intercept. And then the y-intercept is just that constant that tags along, the plus 3. So our y-intercept is 0, 3 as a coordinate. So you plot the y-intercept first, which is at 0, 3. You go 1 across and 2 up, meaning that when x is equal to 1, y is equal to 5. So your next point here, this is your 1, 5. That's your second point. And you just simply rule a line or connect that line that goes through. Now there's a few little things within this example. This is from Miss Huffer's example. There's a few things that I want you to also add onto this line to keep it consistent. Can you please ensure that if the line is not a line segment, if it's not asking for a specific line segment, this line technically goes on forever in both directions. So you need little arrows to indicate this. And another formality that I like to see you guys get into the habit of is actually just writing the equation y is equal to 2x plus 3 next to the line. There are many reasons why behind this. When I was in secondary school, and I'm not too sure if this is the true reason why, but you will have situations where you need to draw more than one line within a graph, and it's hard to reference which line belongs to which equation. So if you just label the line with what the equation is, it's easy to reference because you can see it. It has a certain equation attached to the line. And even though there's only one line that we're referencing, just out of habit, just put that equation in. And when you're sketching your lines, please ensure that you use a ruler. It's pretty self-explanatory, but the amount of unruled lines that I see within methods books, you guys are senior students now, should have a ruler, especially for someone or for students dealing with methods. You need a ruler to be sketching these lines. And also make sure that you label your axes X and Y. Example 2, we have an equation that has 3x minus 6y is equal to 12. Now you can see here that this format is not in the traditional y is equal to some gradient with an x plus minus a c. But we can still go ahead and sketch this. All we need to do is determine what the x-intercept is by letting y equal 0. So when you substitute y equals 0 into this will be 0, and it will be 3x is equal to 12, which we have this line here. Obviously just solve for x by dividing both sides by 3. This is 4, 0. So when x is equal to 4, y is equal to 0, which is this point here. And your y-intercept is when you let x equal to 0, this will end up being 0 minus 6y, so minus 6y is equal to 12. Divide both sides by negative 6, and you will get your y is equal to negative 2. So this point here, our coordinate here, 0, negative 2. Again, arrows. This was screenshots taken off the CastPad calculator, so they don't necessarily have arrows on it. But when you're putting this into your book, make sure you have your arrows. Make sure the axis is labeled. And no, this is not a y equals. This is 3x minus 6y. So always label key points as a coordinate in brackets, x, y, which we have here. That is it for this exercise. You're going to go ahead and attempt the questions from exercise 2D, and I'll see you guys hopefully next day on Wednesday. Best of luck, guys. See you guys soon.